Hello everyone, this is our fourth class of inverse trigonometric function and we have completed up till upper 2.1 exercise. So today we start next topic, properties of inverse trigonometric functions. In inverse trigonometric functions property, we have to learn our first property, that is sine inverse 1 by x equal to, we can write cosec inverse x. Similarly, cos inverse 1 by x equal to sec inverse x. Similarly, tan inverse 1 by x equal to cot inverse x. This one is given as the first point of your property, and for all the values of x n that you know very well, or x is less than or equal to minus 1, for this also same, but for here it is more than or equal to 0, not equal to, only more than 0, because 1 upon x, 1 upon 0 will be infinity. Okay, this is our first property. This one again you can use as a vice versa, means why I write cosec inverse 1 by x equal to, I can write sine inverse x also. Sec inverse 1 by x equal to, I can write cos inverse x also, and cot inverse 1 by x equal to, I can write tan inverse x also. So this is the simple thing, we just prove first of it, and the rest method is same for all. You have to follow the same thing. Let's assume from this side we are taking cosec inverse x equal to y. So what you can take, x equal to cosec y. Now you know, if I write 1 upon x, means what I have written, reciprocal of it. So cosec will be 1 upon cosec. If I write 1 upon cosec y, so it will be sin y. So how can I write y equal to sine inverse 1 by x, taking inverse on both sides. So what we have taken, y equal to cosec inverse x, and we prove y equal to sine inverse 1 by x. So from the first result and second result, you can say that cosec inverse x equal to sine inverse 1 by x. The same way you can prove with cos also. Just I show you the starting, cos inverse 1 by x equal to sec inverse x. Let's take sec inverse x equal to y. So we can take x equal to sec y. Now if I write for 1 upon x, then it will be cos y. Now taking inverse on both sides, so cos inverse 1 by x equal to cos inverse cancel y. So here we have taken sec inverse x equal to y, and we prove cos inverse 1 by x equal to y. What is the meaning of it? It means sec inverse, cos inverse 1 by x and sec inverse x both are same. Our third property, again by the same way you can prove. Let's take third one also. Tan inverse 1 by x equal to cot inverse x. I take first y equal to cot inverse x. So cot y equal to x. Okay, now I want to write 1 upon x. So I can say it is tan y. Taking inverse on both sides. So tan inverse 1 by x and tan inverse cancel. So equal to y. So we have taken y equal to cot inverse x. We prove it is that cot inverse equal to tan inverse 1 by x, because of this and this result. So I think first property, first and this, it's what we say corollary type another property, both one is clear to you, right? Okay, you remember all these properties because we need it in examples. Okay, now our second property. For second, sine inverse minus x equal to minus sine inverse x, cosec inverse minus x equal to minus cosec inverse x, and tan inverse minus x equal to minus tan inverse x. This is your second property. Okay, so let's start with the first proof. sine inverse minus x equal to, let's assume y. If we take it's equal to y, then what you will get? Minus x equal to sine y. Now remember, we have to prove that y equal to minus of sine inverse x. So now what you can write? We can take, if we change the minus sign, then we get in this form, right? But now what we want to make? Equation of y. So what you do? This minus sign, you already know sine is odd function. We already discussed this in 11th standard, that cos is even function, so minus sign will be subside, and sine is odd function, so minus sign will be outside. So if we use this property here, then what you get? Sine minus y. Okay, now what you get? X equal to sine minus y. So what is the meaning of it? We have taken sine inverse minus x equal to y, and we have proved that x equal to minus sine y. So we can take here, taking sine inverse on both sides. So sine inverse sine minus y this way. Okay, now we know sine inverse cancel. So we have sine inverse minus x equal to minus y. And what is it? That sine inverse x equal to minus sine inverse minus x. We shift this minus sign over here. So sine inverse minus x equal to minus sine inverse x. This is the simple proof of first one. Right? Now here we have used only one simple concept, that sine is odd function, so minus sign outside. Okay. Similar way, let's prove second one. Again same. On place of sine inverse x, we have to write cosec inverse. Here also it is cosec y. Here also it is minus cosec y. Here also it is cosec minus y. Rest all this thing is same. Cosec inverse x equal to cosec inverse cosec minus y. Okay, now again same, cosec inverse x equal to y. So what you get? Cosec inverse x equal to minus cosec inverse minus x. We are shifting minus sign over here. So cosec inverse minus x equal to minus cosec inverse x. So similar way you can prove for tan also. So this is the easiest way to prove our properties. Now let's come to the third property. First, second clear, only the difference of a sign that you have to remember. Now third one. In third, terms with given with cos. Third property, cos inverse minus x equal to pi minus cos inverse x. Sec inverse minus x equal to pi minus sec inverse x. And third is cot inverse minus x equal to pi minus cot inverse x. This way we have to prove these three properties. So let's start with first one. We will take first same way proof, cos inverse minus x equal to y. So minus x equal to cos y. Now you know x equal to, if you take minus cos y, then in which quadrant cos is negative? In second. So if you have this, then you can write here only cos pi minus y, because cos is even function. So if I write this way, then I can write cos inverse x equal to pi minus y, and what is your y? Pi minus cos inverse minus x. So if I shift this two term, then what I get? Cos inverse minus x equal to pi minus cos inverse x. This is the easiest way to prove it. Now we will prove for sec. So let's take sec inverse minus x equal to y. So minus x equal to sec y. So x equal to sec pi minus y, because I have shift this sign here. So I can write sec inverse x equal to sec inverse sec pi minus y. Sec inverse cancel, pi minus y. So we can write sec inverse x equal to pi minus sec inverse minus x. We are shifting the term, means sec inverse minus x equal to pi minus sec inverse x. So this way we can prove for sec. Now the similar way let's prove for cot. So we are taking cot here, here cot, cot, same, only on place of cos we have to write cot, otherwise the rest procedure is full same. So this way we have proved our third property. In third property we have terms with cos, sec and cot. In second property we have proved with sine inverse, then cosec inverse and tan inverse. Now come to our fourth property. Fourth one. In fourth one, first is sine inverse x plus cos inverse x equal to pi by 2. Sec inverse x plus cosec inverse x equal to pi by 2, and last tan inverse x plus cot inverse x equal to pi by 2. So now we start to prove from first one. Let's assume first sine inverse x equal to y. So we can write x equal to sine y. Now we will convert this into pi by 2 minus y. This way we can change. Now we can write taking cos inverse on both sides. So pi by 2 minus y. Now on place of y we can write sine inverse. So cos inverse x equal to pi by 2 minus sine inverse x. Shift this sine inverse here. So sine inverse x plus cos inverse x equal to pi by 2. So this is the easiest way how we have proved it. Similar way let's take with sec inverse. Here again we can take cosec inverse x equal to y. So we can take x equal to cosec y. Now we will change cosec into sec, replace with pi by 2. Why we are replacing with pi by 2, you already learned in your 10th class also and 11th also. If you forgot it, then revise it what we learn in 10th standard. Okay, now on place of it we are taking sec inverse on both sides. So sec inverse x, sec and sec inverse x cancel. So pi by 2 minus y. Now on place of y we can write cosec inverse x. So sec inverse x equal to pi by 2 minus cosec inverse x. Shift this cosec inverse x here. So cosec inverse x plus sec inverse x equal to pi by 2. So this way we have proved our first two properties. Now let's start last one, third. So tan inverse x equal to, we are taking y, x equal to tan y. So if you want to replace tan into cot, we can write cot pi by 2 minus y. Now we can take tan cot inverse on both sides. So cot inverse, cot and cot inverse cancel, pi by 2 minus y. So we can say cot inverse x equal to pi by 2 minus tan inverse y. Now shift tan inverse y on this side. So tan inverse y plus cot inverse y equal to pi by 2. So this is your first, this is the second, and this is the proof of third property. This way we have completed fourth topics, all three properties and its proof. Now next property, that is fifth one, and its first one is tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. See, here the first condition is your x into y is less than 1, equal to pi by 2 if x into y will be 1, and equal to pi minus tan inverse, pi plus tan inverse x plus y upon 1 minus xy if your xy is more than 1. So you have to remember this. Similar way, one more thing you have to remember for subtraction. Tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. So this way, this is our fifth property. Now its proof is very simple. We will prove first one. Tan inverse x equal to theta and tan inverse y equal to, let's take phi. So we can take theta plus phi. Okay, theta plus phi I have taken. So what to do? If I just shift this tan on this side, so theta plus phi equal to tan inverse, what is it? Tan x theta only we have written. Wait a minute, I just shift this term only, so it will be more clear and easier for you. Equal to tan inverse x plus y upon 1 minus xy. Okay, now what we will do? We are shifting this tan on this side. So tan inverse is shifted here, so it will be tan. This way we can write x plus y upon 1 minus xy. This way we can write. Now let's start with this side. Tan, what is it? Tan inverse x is theta and tan inverse y will be phi. So we can write tan theta plus tan phi. What is our formula? This is 11th standard's formula. Tan x plus y. Tan x plus tan y upon 1 minus tan x into tan y. Now put up the values. So if on place of tan theta I write x, on place of tan inverse y is phi, so tan phi is y, then upon 1 minus x into y. That way we get the same answer what is your required. Now this way you can prove it. Why here we are getting pi by 2? Because tan inverse plus cot inverse is always 1. We already know it. So this is only you have to remember for minus sign here minus and here plus, and for plus sign here plus and denominator minus. So this is your fifth property. Now I think last one is remaining. So we discuss it today. Okay, last property, that is 2 tan inverse x. Means only simple conversions are given. So let's revise it one more time. 2 tan inverse x equal to sin inverse 2x upon 1 plus x square. Similar way, 2 tan inverse x equal to cos inverse 1 minus x square upon 1 plus x square. And last, 2 tan inverse equal to 2x upon 1 minus x square. Now this proof also you can take by the same concept by which we have proved previous questions. So you have to remember all these 6 properties for sum, because based on it the rest full chapter is on these 6 properties. We will revise one more time all these 6 properties, but do it one thing, that all these properties write it 3 times in your notebook and learn by heart. Okay. So for this class I think enough, and we continue with all the questions in our next class. Thank you.